Okay, sir. A very good afternoon to all of you. On behalf of Department of Computer Science and Engineering, NIT Raipur, and 4th International Conference on Machine Intelligence and Signal Processing, MISP, I welcome all the respected session chairs and participants. Before we start the session 9, let me introduce our esteemed session chairs. So our first session chair is Dr. Sandeep K. Raghuvanshi, sir. Dr. Sandeep K. Raghuvanshi is working as an assistant professor in Department of CSE at Samrat Ashok Technological Institute, Vidisha, Madhya Pradesh. He completed his PhD from Maulana Azad National Institute of Technology, Bhopal in 2019, MTech from Maulana Azad National Institute of Technology, Bhopal in 2009, and BE from Rajiv Gandhi Pradyogiki Vishwavidyalaya in 2004. He has a teaching experience of 18 plus years and having expertise knowledge on machine learning, data science, information retrieval. He has published many papers in international and national conference. He has membership in professional bodies like Computer Science, Teachers Association, IANGE, SCRS, etc. Our next session chair, Dr. Sunita Tiwari, ma'am. So Dr. Sunita Tiwari is working at GB Pant DSEU Okhla 1 campus, formerly GB Pant Government Engineering College. She completed her BE in CSE from RGPV Bhopal, MTech in CSE from IIT Delhi, and PhD in Recommender System from IIT Delhi. She has a teaching experience of 19 years. She has 4 books to her credit, and the latest one was published with McGraw-Hill publication in year 2018. She has published around 30 papers in international journals, conference. 2 of her papers have received Best Paper Award in conferences held Algeria and Canada. She was the convener of the international conference hosted by GBPEC in 2018. And she has also delivered various lectures and resource person in FTP and refresher program. So welcome, ma'am.
Hello.
Yeah. And our next session chair, Dr. Sweta, ma'am. Dr. Sweta Vare is a faculty in Computer Science Department at the University of Richmond. Her research area includes ubiquitous computing, digital health, and machine learning. Her research focuses on developing novel machine learning models for depression prediction using smartphone data. She received her doctorate from the University of Connecticut in Computer Science and Engineering in 2020. She is also an alumna of NIT Raipur, where she completed her BTech in CSE. Welcome, ma'am.
Thank you.
So thank you, sir and ma'am, for joining the session. May I request all the session chairs and participants, please turn on your video. Thank you, sir and ma'am. In this session, we have 5 papers to be presented. So all these 5 papers are from the different institute and different states. And may I request 2 session chairs to start the session?
Yeah, sure. Please.
Yeah. Sandeep, sir.
Yes, please.
Yeah. Now I invite our first presenter, Paper ID 1, Mr. Rahul Srivastav.
Yes, sir.
Yes.
Am I audible, sir?
Yes, yes, audible. Please share your screen and start with presentation.
Is my screen visible, sir?
Yes, yes, visible.
Good afternoon to one and all present in this particular meeting. I'm Rahul Srivastav, hereby presenting my paper entitled as On Diverse and Serendipitous Item Recommendation, a Reinforced Similarity and Multi-Objective Optimization-Based Composite Recommendation Framework. Starting with the table of contents, we have background details, literature survey, problem, methodology, results and discussion, conclusion and references. First, a brief overview about NIT Raipur. NIT Raipur is the Institute of National Importance and located in Raipur City, India, the capital city of Chhattisgarh state. And these are the brief overview of NIT Raipur. We have BTech, MTech and PhD admissions. We have direct admission to students from abroad. Starting with my particular presentation, the background details of recommendation system indicates that it motivates researcher to broaden their focus from beyond accurate recommendation to diverse, novel and serendipitous recommendation. To improve the capability of personalized recommendation system, the multi-objective optimization-based recommendation system is gaining popularity. The superiority of these multi-objective recommendation model is subject to address three significant issues which we can identify. That is, traditional rating evaluation approach limits in the capability towards data sparsity issue, which in turn affects the fitness value of objective function. The elementary objective function lacks in judging the comprehensive strength of associated component metrics, and the relevant recommendation failed to surprise the user with an unexpected yet novel recommendation. Starting with a brief literature review, briefly it indicates that the neighborhood or memory-based collaborative filtering based recommendation system are majorly focusing on improving the accuracy of generated recommendation, but they may not generate diversified novel item suggestions for the user. The recent studies consider only limited non-accuracy objectives like diversity or coverage. Still, there is a need to develop an approach to incorporate more non-accuracy indicator objective functions to enhance the recommendation list's capability in real-world application scenarios. Also, traditional user-based and item-based collaborative filtering approach for unknown item rating evaluation suffers from data sparsity issue. Starting with problem description, this study proposes a multi-objective recommendation framework to recommend diverse and serendipitous items by simultaneously optimizing conflicting objectives, including accuracy, diversity, and serendipity. We designed objective function for diversity and serendipity by incorporating their associated component metrics and strength by enhancing the strength for improving the capability of recommending unexpected, novel yet relevant items. This study employs reinforced similarity computation-based rating prediction model to improve the fitness of objective function. The performance of MORF is compared with baseline using Pareto front and evaluated with accuracy and non-accuracy based measures. This is the framework where we have a rating matrix and a fitness function, which indicates fitness function for accuracy, fitness function for diversity, and fitness function for serendipity. Fitness function for diversity includes topic diversity and inter-user and intra-user list diversity.
Participant, please be muted.
Fitness function for serendipity includes relevance, distance-based item novelty, and surprise. This is a reinforced similarity-based rating prediction model, which obtains the similarity between users. And further, the multi-objective recommendation framework using genetic algorithm operators are applied to find out the Pareto optimal trade-off recommendation solution. The MORF shown in figure 1, it includes enhanced reinforced similarity-based rating evaluation model and the objective function for accuracy, diversity, and serendipity. This is the equation 1, which describes the reinforced similarity-based rating prediction model. where we obtain the similarity between two users, and similarly similarity between items can be obtained vice analogously. Same. These are the objective functions for accuracy, diversity, and serendipity. These objective functions indicates that accuracy is majorly concerned for including relevant and popular items in the recommendation list, as user has a prime focus towards gaining a item recommendation of popular item. And diversity and serendipity are objective functions are majorly targeting to items to recommending items which are of different genres, which can surprise user with unexpected suggestions. Surprise here means a positive surprise or a pleasant surprise. These are few results which we have obtained over two data sets, movie lens and Gesture data set. The first, it describes the Pareto front obtained over a movie lens data set, and this is for a Gesture data set. Here we have considered accuracy and diversity as two objectives in both A and C. And here we have considered accuracy, diversity, and serendipity as three objectives over movie lens and Gesture data set. The red one shows the performance of baseline model PMOEA, and the blue one shows the performance of proposed MORF model. The precision-based and diversity and novelty-based evaluation measures are adapted for evaluating the performance of MORF using both the data sets. We observe one interesting thing, that is UBCF, that is the user-based collaborative filtering, exclusively focusing on improving the users accuracy in terms of users preference. That is why user precision for UBCF is better than proposed MORF and even baseline PMOEA. But the topic diversity, intra-user diversity, and serendipity for the MORF is we outperforms the other baseline models. This study was undertaken to design the evolutionary optimization-based recommendation framework and establish the trade-off relationship between conflicting objectives, including accuracy, diversity, and serendipity. The key strength of this study, first is incorporating the reinforced similarity-based rating prediction model. Second is to design an objective function for diversity and serendipity by also considering its component metrics. Finally, establishing a trade-off recommendation solution by employing NSGA2-based evolutionary optimization approach. The extensive experimental and evaluation results indicates the superior performance of MORF over the other baseline models, and in terms of delivering a diverse, unexpected, novel yet relevant recommendation solution. These are few references. Thank you.
Any query from the session chair?
Can I?
Yes, ma'am. Yes, Sunita, ma'am. Yes.
Hi, Rahul. How are you?
Thank you, ma'am. I'm fine, ma'am.
Rahul,
Yes.
what are the performance matrices you used for novelty and diversity? First question.
Yes, ma'am.
How did you ensure that novelty doesn't affected the accuracy,
Yes, ma'am.
precision, and recall?
Yes, ma'am.
Well, most importantly, precision.
Yes, ma'am. Answering first question, for evaluating the diversity, we have two measures: topic diversity and intra-user diversity. With topic diversity, we are making sure that user is getting recommendation from various genres of a movie or of a joke. And with intra-user diversity, we are evaluating the diversity of two users and checking that both the diversity component or the item is recommended to both the users, satisfy the inter-user diversity constraint or not. And
what do you mean by intra-user diversity? If you and I are two users,
yes,
how would you explain it?
in terms of let's consider the intra-user diversity in terms of genre only. If you are getting a set of genres as a recommendation for a set of items, and I'm getting a set of recommendation for the set of items, and if the similarity between two of us is a positive or having a relevant similarity, and we are getting the same kind of item recommended, that means there is no intra-user diversity. So to enhance this particular component, we are establishing a trade-off. We are checking intra-user diversity so that both user or even a similar users are getting diverse set of elements to enhance the capability of recommendation list. And answering the second question, that is why we have incorporated the multi-objective scenario and optimization scenario here, to make sure that by enhancing serendipity or surprise or diversity, it is in a trade-off with accuracy or precision. And so that is why we are obtaining a trade-off recommendation solution after the optimization performed.
So have you checked the precision before applying this diversity and novelty thing, and without novelty and diversity objective function, and after that?
Okay, ma'am.
What is the
Particular,
effect of novelty
yes,
and diversity? Because precision for sure is going to change.
yes,
If I am having 5 items, 3 were relevant and 2 were non-relevant, if you add on a novel recommendation, there is a
yes,
high possibility that
yes.
that won't be relevant to my test, right?
Yes, ma'am. That is a very good perspective that we will add, ma'am, and it is a very very creative way of doing the things. Although we have incorporated the results of UBCF and PMOEA, that is without establishing trade-off. Those precisions are in such a way that they have not established, like UBCF is totally accurate, totally dedicated for precision. But yes, definitely I will incorporate that particular point so that MORF capability can also be compared without trade-off and with trade-off. Thank you, ma'am.
Sure. And one more thing,
Yes, ma'am.
coverage.
Yes, ma'am. With coverage also.
Good, good.
Thank you.
Thank you.
Thank you.
Hi, Rahul, I have a quick question.
Thank you.
Well, it was
Thank
a great presentation. Thank you.
Thank you, ma'am.
Can you briefly describe your data set? Just
Yes,
like
ma'am.
what are the variables
Yeah,
that you
I
have
should
in the
have
data set?
included. Yes, ma'am. I should have included dataset description. Dataset, two dataset we have used, ma'am. Movie Lens and just a dataset. Movie Lens 100K dataset incorporates 100K ratings from 938 users, 938 movies of and 1683 users. And similarly, just a dataset have similar kind of statistical description, ma'am. I need to incorporate it.
Yeah, sure, not a problem. And can you also describe the third equation? I think you talked about diversity and accuracy, but
Yes,
for
ma'am.
serendipity,
Yes, ma'am.
like, yeah.
I'll describe it. This is the main objective of serendipity is to enhance the pleasant surprise for user. Now, pleasant surprise can be enhanced by analyzing the likelihood of user's likeliness. So this particular equation, which describes the probability for item I and item J to be rated by any user, and to be rated, and secondly, we identify to be rated by the group of users. Both we are taking into the consideration, so that the surprise element should be a pleasantly surprise. It should not be a shocking surprise.
Okay. Yeah, makes sense. Thank you so much.
Thank you, ma'am.
Yeah, hi Rahul.
Thank you, sir. Yes, sir.
How are you?
Fine, sir. Thank you.
Okay. So I also have a couple of questions for you. Like,
Yes.
how do you comment on the scalability part of this particular pattern?
Yes, sir. Although we have not incorporated that part, but that is a very good incorporation that we may do to test the scalability. One way is to check or to distribute the data in different training parts and check the precision, diversity, and novelty. And in different test case condition, we can include to check, we can incorporate to check the scalability. Like I explained about training set of data, or similarly, we can incorporate genre selections based on a test case of genre selection. We can do the scalability test. I will definitely incorporate that.
Now, the second is like, what do you think? Like, what is the feasibility of this algorithms as a practical way? Like, let's suppose I have to implement it for my own recommendations.
Yes, sir. In a practical, in a real-time manner, one difficulty or one limitation I can say that it is working on a multi-objective optimization that is through evolutionary optimization. So it goes for various iterations, and so long data set creates difficulty. But somehow we can incorporate those multi-objective optimization with different small sets of data, so that commercial applicability can be easy.
See, when we go for the real implementations of recommendations,
Yes.
we have to have some scheduled updations in the model,
Yes,
because
sir.
the new data is coming at a regular pace.
Yes, sir.
People are changing their ratings, or they may also change their taste. Like
Yes.
previously, like you might like comedy movies, but let's
Yes.
suppose now you are more comfortable with crime-based movies, or some
Yes.
serious movies are there. So these tastes of the users are changing by the time.
Yes, sir.
Okay, now when it happens, like you need to have a scheduled maintenance of the data set.
Yes, sir.
How do you comment on this particular algorithm? Like, how you cope up with these changes? Like, do we need to train a whole model again, or like we can have some incremental way of executing things like that?
We have definitely can have an incremental way of doing the things, sir. And in set of 1 million rating, this particular model is not. I have tested this particular model in Movie Lens 1M also, and it is executing fine and creating a set of recommendations for the user in a significant exponential amount of time. But definitely in a real time updation, we have to go through a incremental way of doing the things, as you said.
One thing that you can do is to test the scalability. Like you can try the different version of movie lens data. Like you can have the current one is I think 100K that you are using.
100K is old one, sir, and currently we have larger ones.
No, what you are using? Like you are
Yes,
using 100K or the
100.
1 million one?
100K for
Okay,
this.
so now you can
data.
try with this 1 million or 5 million or 20
Yes.
million data
Yes.
versions are out.
Yes.
Okay, thank you, Rahul.
Thank
Thank you very
Thank
much.
Can I add one more thing, Rahul?
Yes. Yes.
Are you training model online or offline?
Currently offline, ma'am.
Of
But,
course, offline. The training of model, genetic algorithm or evolutionary based algorithm is mostly offline. So,
Yes.
sir's question can be answered from that perspective.
Yes. Yes.
Consider that also.
Yes.
That understanding also that the training is mostly offline. You can schedule it in background
Yes.
after a certain period of time. So think about it.
Yes, ma'am. Thank you so much, ma'am. Thank you, everyone.
Thank you, Rahul, presenting your paper.
Thank you.
Now I invite our second presenter, paper ID 29, Mr. Vivek Upadhyay.
Good evening. Am I audible?
Yeah. Rahul sir, please unshare your screen.
Yes.
Yeah, Vivek, please share your screen and start with your presentation.
Is my screen visible? Hello.
Yeah. Visible.
Yeah. Good evening, everyone. Respected teachers and my dear friends. My name is Vivek Upadhyay, and today I want to start with the topic enhancing agricultural outcome with multiple crop recommendation using sequential forward feature selection. I am currently at the 4th semester MSc Statistics and Computing from Banaras Hindu University, and along with me there are 4 other co-authors. And this is my first presentations. I thank MISP 2022 for giving me the opportunity for presenting this paper. Let us start with the table of contents. So we have background, literature survey, problem description, methodology, results and discussions, conclusions and references. So background, there has been a lot of research in the field of agriculture, especially mentioning crop recommendations in precision agriculture. There has been many machine learning models to predict the agricultural crops with the help of different features. Our effort has been to build a recommendation system for precision agriculture to help our country's farmers to grow crop available to them with ease. Our main objective would be to develop a model having maximum accuracies with the help of minimum number of features. So the main problem with our farmers is that they are not able to choose the right crops based on the various factors. And also the another problem is that in many areas all the government data are not available. Suppose in some places humidity may not be available, data of humidity, some places potassium may not be available. So our main objective was to choose a model, recommendation model with the minimum number of features possible without compromising the accuracy, so that we can get the multiple crops recommendation. So we have studied many papers, but basically we have systematically compared one paper named agro consultant intelligent crop recommendation system using machine learning algorithms. The authors have prepared a crop recommendation system with the help of soil characteristics and environmental characteristics. They also built rainfall prediction model and visual mapping. They have obtained 90.2% accuracy in the decision tree classifier, 89.78% in KNN, 90.43 in random forest, and 91% in neural networks. So our objective would be to increase the accuracy and also to use the minimum number of features, and also to get the multiple crop recommendations, so that our farmers would get choice to cultivate the best crop or the second best crop, looking at the factor of demand and supply. Let's look at the problem description. The demand for food in the world tends to increase day by day with the rise in population. Also, our farmers are unable to choose the right crop, considering the factor of chemical and topological factors of soil. Our farmers are unable to make optimal profit from farming due to lack of knowledge and demand and supply. Let's look at the methodology part. So first we have the data set which we have obtained from publicly available data set. Then we have prepared our data through feature extraction and feature selection. And we move towards the modeling part. Machine learning, we have used various machine learning models like KNN, naive and all, and we have compared, and with the best possible accuracy, we have moved toward model evaluation, and then we have used for hello. Okay, let's move to the methodology part. So our data set is a secondary data set collected from Kaggle. The data set was built by augmenting data sets of rainfall, climate, and fertilizer data available for India. Our data set has 2,200 entries in 8 fields, 7 features: nitrogen, potassium, phosphorus, temperature, pH, humidity, rainfall are present in the data set. A total of 22 crops are present in the data set. So we have used the forward feature selection sequentially. So it is an iterative method for feature selection. We start from no features, then each iteration we add features. Addition is done until there is no further improvement in performance of the model. We have used accuracy to measure the performance of trained models. We have used the following classifiers in our solutions: decision tree, support vector machine, naive classifier, and k nearest neighbors. To evaluate the efficiency of our model, we have used the following measures: accuracy, precision, recall, F1 score. Finally, let's move to the results and discussion part. So after preparing the model using the sequential forward feature selection and with the naive-based classifier, because it was giving the maximum accuracy, we move towards the main part. So we have put after preparing the model, we have put the model with this particular 4 inputs because we are getting the maximum accuracy in this 4: so nitrogen, potassium, humidity, and rainfall. So putting this input, we got this following output. So this is just one of the case study of what our model is giving. So we saw that the kidney beans was giving that the particular area having these features, kidney beans was most favorable with 0.759 probability. It was followed by pigeon peas, and others have comparatively less probability. So our farmers could decide based on this. So in this particular situation, kidney beans was favorable, but they could consider another thing: if all the farmers were planting kidney beans in that particular area, so based on this, they could choose the pigeon peas, looking at the factors of demand and supply. Because if every farmer starts planting the same crop, then definitely there would be loss. So let's see let's compare our proposed model and with the existing model, which I had already mentioned earlier. So in decision tree, we had our model has obtained this 0.97, and the existing model has 0.902. Similarly, the highest accuracy we have obtained in naive-based classifier, and so we use the naive base for these predictions. Let's come to the conclusion part. In this work, we have used a sequential forward selection to identify multiple crops for agriculture on different terrains of India on the basis of different features. The proposed work has provided significant results on publicly available datasets. In our future enhancements, we want to build an application so that it could be directly used by the farmers. And also, we need to collect real-time data and implement to our models, because it is a secondary data, so it may have limitations in the practical. So we need to find a way to predict what fertilizer to be used for specific crops. We have used various references. Some of them are just few of them are mentioned in these slides because due to space limitation. Thank you.
Any query from the session chairs?
Should I start?
Yes, ma'am. Sure. Yeah.
Vivek, hi.
Hello, ma'am.
Yes. Can you go back to the results slide?
Okay, ma'am.
Right. Second slide of results. Right.
Okay, ma'am.
So you are telling me that you have a data set of 2200 entries, right?
Yes, ma'am.
And all the
Yes, ma'am.
data is in Indian data, right? Or you have
Yes,
added
ma'am.
some rows in for Indian data? I'm just asking
No,
that.
Indian. No, it's Indian data.
It's entirely Indian data. So first
Yeah.
2200 rows, the 2200 this data is very, very limited data at first place. Secondly, this comparison, the first row says decision tree is your model is giving 97.66, then existing model is giving 0.902. What is that existing model doing? Is it also based on decision tree?
Yeah, based on decision tree. But what my work want to suggest is that that sequential forward selection technique, and before that we have used the PCA. We have not used directly PCA, but we had used PCA to get an idea that how much minimum number of features we can get, and also with the help of this sequential forward relation techniques, and there were various other techniques like correlation matrix, mutual informations, etc. We had actually worked on the data pre-processing segment. So what I want to say is that due to those our feature selection techniques, maybe we have got this amount of accuracies.
Okay, so your claim is because of data pre-processing and feature selection approach, you are gaining a accuracy improvement of around 7%, right? It is 90%
Yes,
and yours is 97.6 rather, right? And similarly, in
yes,
second case, KNN also, there is a huge difference, right? 89 and 96. How
yes,
come you achieved this in KNN? Same reason?
yeah, ma'am, actually.
And for both the implementation, you have used same environment.
Yes, ma'am.
आपने उनका भी मॉडल इंप्लीमेंट करके देखा है, right? Or you have picked up their accuracy?
Actually, I have picked up their accuracies in from their paper. I have not implemented.
But they have used the same data set, right? आपने
No,
comparison
their data
किया,
set was yeah.
उनका
Yes,
data set different है, ऐसा कह रहे हो?
yes, actually उनका data set कौन है वो हमको मिला नहीं, उससे
But फिर
actually
कैसे
search किया था.
कंपेयर होगा? Environment totally different हो गया. आपका data set different है, उनका data set
So yeah,
different है.
but
Right? So
उनका भी
consider
implementation.
this also, है ना? क्योंकि totally different हो गया.
Yes,
आपने अपने data set पे उनका algorithm चलाया नहीं. First thing. Second thing, आपका data इतना vast नहीं है. जैसे first case में movie lens है, 1 million set of data है, तो हो सकता है कि cases cover हो जाए, right? But 2200 rows में सारे cases cover भी नहीं होंगे. So you should work on that in future. Right. Okay. Thank you, Vivek.
Okay. Yes, ma'am.
Hi, Vivek. It was a good presentation.
Hello.
Thank you. I have a couple of questions. Did you use any hyperparameters like, cost or tree depth as applicable?
No, ma'am. No, ma'am.
Okay. And can you go back to the previous slide number 11?
Yes, ma'am.
So I'm a little bit confused on your input. Like when you say you have selected features, right? So it should be out of like 2200 entries, right? But you're pointing to some specific values like 30, 23, 18, and 174.
No, ma'am. No, 22 entries is just we are pointing this 30, 23 is that Specific, we have suppose that nitrogen it is 30 units, potassium it is 23. So this is one of the case studies. So similarly, if we change these numbers, then these probabilities will be different.
Okay. Yeah, I'm not sure about this part. When
Yes,
you run
ma'am's question also adds on here that cost is not considered. If I am a farmer, I would be selecting a crop which gives me more benefit. MP soybean pe zyada jayega, right? Rather than kidney beans.
Yes.
You should consider
Yes,
this
sir.
factor. Consider as
we'll add to.
Yeah.
Yes, ma'am.
Is
We'll
it
add to.
available in your data, Vivek? Hi. Is
Yeah,
this
yes.
field available in your data? The cost field is available.
Cost field is, yeah. Cost field is not available in your.
Okay. Okay. So follow-up question. Can you go back to the same slide where you are showing the comparison?
Yes, sir.
See, I would like to add a few things like you're talking about the comparison between decision tree or proposed model and existing model. And decision
Yes,
tree itself has the capability to identify important features. I guess you know it.
yes, sir.
Yeah. So
Yes, sir.
like
Yes, sir.
the feature engineering is not very effective on decision tree kind of models. Like when we say that if you go with all kind of features, it is automatically able to identify what are the important features, and basically we draw a decision tree based on that. So
Yes.
and here like getting a difference of around 7% accuracy is somewhat surprising me. And maybe that's the reason is like you don't know what was the data set of the literature paper and the data set of your paper instead. So the
Yes, sir.
first thing which I would like to tell you, like when you go for the comparison, try to make on a standard pattern. Like you have to match the experiment parameters, you have to match with the data set, and even with the environment also, like what are the hyperparameter settings and all these things. Then only it's good to give the comparison. Okay? अभी तो ये ऐसा हो गया ना कि हमने एक को सड़क पे दौड़ा दिया और एक को हमने रेत में दौड़ा दिया, and then we are trying to make a comparison who is fast or who is slow. You have to take
Yes.
both of them onto the road, either or onto the sand. Okay.
Yes, sir.
Yeah.
Yes, sir.
Anyway, thank you, Vivek. Thank you.
Just a quick
Thank you, sir.
follow-up. It's something very basic, but still asking, did you scale your parameters? Like, did you scale your features? For example, did you normalize them in the same range before running the classification? आपने उसको 0 से 1 के बीच में जैसे एक साथ स्केल किया था?
नहीं मैम, वो स्केल नहीं किया था, वो पहले जो किया था वो.
हाँ, तो आपको कोई भी फीचर बिफोर इवन यू रन क्लासिफिकेशन आपको शायद उसको स्केल करना चाहिए, राइट? क्योंकि द रेंज ऑफ वैल्यूज विल बी डिफरेंट. फॉर एग्जांपल आपका कोई फीचर मान लीजिए 1 से 10 के बीच में वेरी कर रहा है, 1 उसकी मिनिमम वैल्यू है, 10 उसका मैक्सिमम वैल्यू है. फिर दूसरा फीचर जो है वो लेट्स से 10 से 1000 तक जा रहा है, राइट? सो दे आर नॉट like when you pass them to a classifier, they are not in the same scale. So the first rule when you run any classifier is you scale them, you normalize them. आप ये भी try कर सकते.
Okay.
Thank you.
Okay, thank you, Vivek, for presenting your paper. Yes. Now I invite third presenter. Presenter paper ID 259. Nishan Singh Hada.
Yes, sir. Please.
Yeah. So you are presenting paper?
Yes, sir. Yes, sir.
Yeah. Okay. Okay. Go ahead and start with your presentation. Yeah.
Yeah. Am I audible and my screen is visible, sir?
Yes. Yes. Visible.
Yeah. Good evening, one and all. I am Sriram Mala from NIT Hamirpur, and I am going to present our paper titled Novel Recommendation System for Vaccines Using Hybrid Machine Learning Model. ID is 259. Okay. And these are the table of contents: background, literature survey, problem description, methodology, results and discussion, conclusions, and references. Now, if you see background, actually the journey from the discovery of first vaccine by Edward Jenner in 1796 to the continuous work being done by the medical researchers over the continents on COVID-19 vaccines is remarkable. So for various diseases, and not just COVID-19, there have been multiple vaccines from different manufacturers. So the efficacy rate of vaccines varies from region to region and from person to person, that we know. And because of substantial variation in how an individual's immune system responds to the vaccine. So the study conducted by Petra Zimmerman et al. Investigates and talks about various factors that influence vaccine responses in humans. So this is some of the literature survey which we did. So Stock et al. In 2017 presented an approach for drug recommendation system. Actually, in literature, we have many drug recommendation systems. Okay. So, and these authors considered the individual features of the patient and they assigned scores to the drugs. So they assigned scores to the individual drugs and the drugs with highest relevance scores were recommended. And if you see another work which is done by MD Hossain et al. In 2020, they implemented a drug recommended system that applied sentiment analysis on drug reviews to generate rating on drugs. And if you see another study that is done by Weibao and S. Jiang in 2016, they implemented a recommendation system for medicines using data mining models like ID3 decision tree algorithm, backpropagation neural network, and support vector machines. But there is no recommendation system for vaccines. That is which we found in literature survey. Okay, so this is the problem recommendation. So over the last decade, we saw various recommendation systems for drugs with common goal to consider all factors quantitatively and help the medical officers in decision making. But this field is unexplored for vaccines. Like I said, there is no work done in vaccines, like vaccine recommendation. Okay, so here we created a similar system, but for vaccines. We created a similar system like drugs for vaccines. Now that produced decisions after considering host-based and vaccine-based factors. So the decisions are made based on host-based and vaccine-based factors. Our system considers data points like age, sex, and medical history, and allergies of host, and recovery rate, death rate, and after vaccination, what are the symptoms of a host, okay, to make a recommendation. Okay, so this is our system. So if you see,
yeah, please continue.
I think you're mute.
Srinu, you are muted. Srinu, please unmute yourself.
yes, sir.
Yeah,
Okay.
Start. Yeah, continue.
Yeah, so if you see our methodology, then our system stands upon a score-based algorithm that utilizes machine learning to recommend the right vaccine. And our system takes age, sex, disease type, and medical history as input. And we extract the important attributes and required rows based on input from vaccine adverse event reporting system dataset. So we extract some attributes and which are required rows. Okay. So from VRS dataset after multiple steps of pre-processing. And the system then score different vaccines for given type based on defined criteria. And finally, the vaccine with highest score is recommended to the user. Okay. And this is the scoring criteria which we adapted in our methodology. So the scoring criteria is each post-vaccination death and recovery contributes -2 and +1. So after post-vaccination, if it is death, then it contributes -2, and if it is recovery, then it contributes +1 to the score of a vaccine respectively. Now, again, the textual data, that is allergies and history in the data set, are fed to the count vectorizer and then to TF-IDF transformer to extract the features. Okay, so we have used count vectorizer and TF-IDF transformer. Okay, and we have extracted the features. Okay, now the user input medical history is also fed to the same vectorizer and transformer to break down into tokens. So we input the same medical history to the count vectorizer and transformer, which will break down into tokens. Now, both these inputs are fitted to the logical regression classifier to generate prediction probabilities. Okay, so we fit this two into the logical regression classifier, which will generate prediction probabilities. Okay, and most probable vaccine will contribute the least score towards vaccine recommendation. The reason behind this statement is that the system matches history of patient with post-vaccine symptoms. Means higher the similarity, worse the vaccine. Right? So the scores generated from the classifier for each vaccine is inverse of its probability. Okay. So finally, the scores are normalized, and the vaccine with 1.0 score is recommended by the system for particular patient. Okay. And we have conducted some experiments, and we are sharing the results. So it is given in results and discussion part. So we ran the system for COVID-19 and flu 3 on 8 different kinds of simulated patients data. Right. So these are the normalized scores for COVID-19 vaccine from experiment 1 to 8. Right. So we have given in one case. Okay. So it has given the output 0.1 and 0.112, right, and 1.0. Means for this host, the recommended vaccine is Jason. Okay. Suppose if it is not available, then the next highest score vaccine will be given to the host. Okay. So like that, in experiment 2, we have given 2 inputs. So based on that, it has produced result. So these are the results. Now 1.0. Now the recommended vaccine for the second host is Moderna. Okay. It depends on the host features like age, sex, and then what was his pre-existing diseases. So based on that, it will recommend the vaccine. Okay. So like that, we conducted 8 experiments for COVID-19. Okay. And for flu 3 also, we have conducted experiments 9 to 16. And in this case, it has recommended this type of vaccine. So as this 1.0, so this vaccine is suitable for this subject. Okay. Now, if this vaccine is not available, then the next highest score vaccine will be given, that is 0.9844. Okay. So like that, we have conducted experiments up to 16. I mean, these are the subjects. Okay. So coming to the conclusion, our system is first of its kind that recommends vaccine based on the patient's age, sex, medical history, and allergies. Okay. And the score-based algorithm displays the score of not just the recommended vaccine, but it also provides the results for other vaccines to allow medical officers and other researchers to compare the vaccines for different patients. So in the results, we demonstrated the working of our system for COVID-19 and flu 3 vaccines, and we can clearly observe the difference in scores generated by the system for different patient data. Okay. So as of our experiment, we got a limited data set. So in future, we will expand our study on the detailed data set. Okay. And we are trying to gather the data of Indian data. Okay. And in future, we will work on this vaccines, that is Indian vaccine data set. Okay. these are some reference which we used. Thank you. That's all from my side.
Any query from the session chairs? Yes, ma'am. Sunita, ma'am. Yes.
Sir, can you go back to the results?
Results. Yes, ma'am.
Look at the first experiment set of eight users or patients.
Okay.
You can see that in case of the third vaccine, most of them are recommended with the third vaccine. Only one is an exception, right?
Yes, sir. Yes, ma'am.
And that exception has been recommended the second vaccine, right?
Yes, yes.
First vaccine is not recommended to anyone,
Yes,
right?
ma'am. Yes, ma'am.
Similarly, if we go back to the second set of experiments, you see that most of them were recommended with one vaccine. The second set, most commonly the second set, that is CSL limited vaccine. 4 of them were recommended with CSL, and very few are recommended with other. So if I analyze it as such, your parameters are not much affecting if either all the patients are of similar nature, or it is your algorithm is not affecting your inputs are not affecting the decision. You understand my question?
Yes, yeah, I understand, ma'am.
Yes. So
So actually, this Jason is very effective vaccine, madam, for all age groups and for all, I mean, pre-existing diseases, madam. So most preferable vaccine is this one, madam, Jason. So we have tried, but it is giving Jason is most effective vaccine.
but the first one is getting similar value. Look at that, 0.1 for everyone. In the other cases also, in the second set of experiment, most of them are getting 0.1 in the lower side of metrics. So I am just wondering whether your aim is achieved or not. I'm just wondering that.
Yeah, actually, we are studying more on this, madam, and we are trying to adapt other machine learning algorithm which will give a perfect vaccine. As this is beginning,
because if it is already known that this one is the best vaccine available, why would a user use your recommender system? That is my first question. Being an end user, why would I go with some recommendation if I already know that vaccine A is best for me, right? If it is not personalized enough, if everybody is getting that vaccine, it is not personalized, right?
But if you see this one, madam, means experiment 2, then in this the modernized preferable means. So
what are the reason? Have you analyzed that only this user is getting different result?
Yeah, this is because of patients' preconditions and age factor and other criteria.
If that is the case, please bring that to the discussion also, because if that is an exception, why that exception is there? First suggestion. Second, where did you get this data set, the input data, the 8 subjects?
This is from VARS data set, madam.
All right.
Vaccine adverse event reporting system data set is there, no, madam. So from that we have extracted some features and some rows.
Did you compare it with other papers